Assalamualaikum and very good morning, Doctor and fellow friends. My name is Muhammad Haji Hakimi bin Muhammad Sufyan, metric number S76681. Today, I will be presenting about corrosion protection method, which a special focus on a method called Impress Current Cathodic Protection ICCP. Let's start with the introduction. What is the goal of corrosion prevention? Simple. We want to protect the surface to maintain the material integrity. Kalau kita tengok flowchart ni, protection method boleh dibagikan kepada 3 metod utama. Yang pertama adalah change of environment. Contohnya, kita buang oksigen atau kelembapan dari kawasan tersebut. Yang kedua adalah change of metal. Kita ubah komposisi metal. Mungkin kita boleh guna alloy yang lebih tahan lasak. Yang ketiga adalah design improvement. Ini yang paling biasa kita guna, iaitu menggunakan coating atau electrochemical protection. So, pemilihan metod ini bergantung kepada environment. Adakah ia di udara biasa atau terendam di dalam air laut? First type of protection is coating. A coating is a liquid that forms solid continuous film to protect a substrate. There are 3 main mechanisms here. First, barrier coating. Ni macam cat biasa, dia form satu lapisan non-porous. Tapi ingat, kalau lapisan ini calar sikit je, substrate di bawah tu terus tak dilindungi. Second is inhibitive coating. Yang ini dibentuk satu lapisan pasif bila bertindak balas dengan metal dan kelembapan. Third, sacrificial coating. Dalam cat ni ada bahan tambahan macam zinc yang akan berkorban atau corrode dulu untuk selamatkan besi di bawahnya. Seterusnya, kita akan beralih kepada corrosion inhibitor dan anodic protection. Inhibitor ni adalah bahan kimia. Bila kita tambah dalam sistem, dia akan kurangkan kadar Kakisan tanpa ubah concentration agent pengaratan. Dia bertindak dengan membentuk filem nipis pada permukaan, sama ada secara passivation, precipitation atau absorption. On other hand, anodic protection is quite specific. Teknik ni jimat kos, tapi dia cuma berkesan untuk logam jenis aktif pasif, seperti stainless steel. Dalam persekitaran asid, contohnya asid sulfurik, ia menggunakan arus elektrik untuk kekalkan metal tu dalam keadaan pasif. Next type of protection, cathodic protection. Konsep ia sangat senang. Kita jadikan satu struktur besi kita tu sebagai kathod supaya dia tidak berkarat. Ada 2 cara. Yang pertama adalah sacrificial anode. Kita lekatkan logam yang lebih reaktif, seperti zinc ataupun magnesium, pada struktur kita. Logam ni akan berkarat demi menyelamatkan struktur besi tersebut. Yang kedua adalah Impress Current Cathodic Protection, yang ICCP. Yang ini kita boleh guna logam korban semata-mata, tapi kita guna kuasa luar ataupun external power. Impress Current Cathodic Protection. What is ICCP? Impressed current cathodic protection is a system that employs a direct current power source to provide the protective current. Why we use it? It is used to protect large structures like ship hull, pipelines, where sacrificial anode might not provide enough current or longevity. How does the system physically work? Please look at the diagram. The circuit consists of three main parts. First is the structure, such as this steel pipe or platform, act as the cathode, the negative terminal. Second is an auxiliary anode is placed in the seawater. Third is a rectifier connect them. The rectifier forces current to flow from the anode through the seawater and onto the steel structure. By flooding the steel with electrons, we prevent the steel on iron from leaving the surface, effectively stopping corrosion. The polarization process. The science behind this is called polarization. To protect steel surface in seawater, we need a polarization dam to a specific potential, typically negative 0.85 volt relative to a reference electrode. We adjust the power supply voltage until the iron potential matches the open circuit potential of the local anode. A polarization diagram is often used to calculate exactly how much current is required to achieve this state. System component. The hardware used in ICCP is distinct from sacrificial system. First is power source. We use rectifier, battery or generator to supply the DC current. Second is anode. We can use expandable steel anode, but more commonly we use permanent material like platinum. These permanent anodes are designed to be slowly destroyed or not destroyed at all, giving them a very long lifespan. Reference electrode. We install a standard half cell to constantly monitor the potential and ensure the system is working correctly. Application. Where is ICCP applied? It is standard in the marine industry. It protects first is ship, specifically the hull and rudder. Second is offshore floater, such as oil rig and platform, subsea equipment and pipeline, harbor and tank, including jetty and storage facility. For those massive structures, ICCP is more cost-effective and manageable than a sacrificial anode in long run. Limitation of ICCP. However, ICCP is not without its limitation. First is maintenance. It requires regular maintenance. You must check the rectifier and replace anode periodically. Second is mechanical damage. It protects against chemical corrosion, but offer no protection against mechanical damage like impact or scratches. Third is conductivity issue. The protection relies on the current flow if the hull is shielded by non-conductivity material, or if the water has high electrical interference, the protection may not be effective. Conclusion. effective corrosion protection is vital for safety and longevity. We have looked at coating, inhibitor, and electrochemical method, while simple method work for small components. Impress current cathodic protection is the superior choice for the large-scale marine infrastructure. It provides a controllable and powerful defense against the harsh marine environment. That's bring me to the end of my presentation. Thank you very much for your attention.